It is almost impossible to imagine the modern world without electricity. Electricity plays a crucial role in almost every aspect of our lives. Considering this growing demand for electricity, scientists have long been striving to find ways to produce more electricity at a lower cost while causing less harm to the environment. As a result of their efforts, nuclear power emerged as a viable solution. For instance, while generating 1 unit of electricity from coal releases 820 grams of CO2, a nuclear power plant produces only 12 grams of CO2 per unit of electricity. Today, we will discuss how nuclear power plants generate electricity efficiently at a lower cost. A significant portion of the world's electricity comes from thermal power plants. In these plants, electricity is generated using thermal energy, which is derived from conventional fuels like oil, gas, and coal. On the other hand, nuclear power plants use uranium-235 isotopes, which have a mass number of 235, as their primary source of thermal energy. The specialty of uranium lies in its behavior when bombarded with neutrons. When a neutron strikes a uranium-235 atom, it transforms into uranium-236, making the atom unstable. This unstable uranium atom undergoes 4 significant changes. 1. The uranium atom splits into 2 entirely different elements, krypton and barium. 2. Radioactive rays are emitted. 3. Thermal energy of about 200 MeV is released. 4. 3 more neutrons are emitted. The newly released neutrons then strike 3 more uranium atoms nearby, initiating a chain reaction known as nuclear fission. The thermal energy of 200 MeV released from each fission reaction is ultimately used to produce electricity. Let's take a look at the diagram. This is the overall structure of a nuclear power plant. A nuclear power plant primarily consists of 4 main parts: the reactor, the steam generator, the electric generator, and the cooling tower. The uranium bundles are placed inside the reactor, along with control rods positioned between the uranium bundles. These control rods are made of materials like boron, cadmium, silver, or indium. The role of the control rods is to regulate the nuclear fission reaction inside the reactor. They do this by absorbing neutrons. For this reason, the control rods are designed in a way that allows them to be inserted into or withdrawn from the reactor as needed. After the uranium bundles and control rods are installed, the entire reactor is filled with water.